Forget what you knew about life on Earth. By 2100, it's no longer the world we're accustomed to seeing. Modern problems such as environmental pollution, resource depletion, and climate change will compel humanity to seek new paths for survival. What will the world be like when humanity leaves its historical home and resettles on another planet, on Earth 2.0? The rapid rise in global temperatures could render much of our planet uninhabitable by 2100. Scientists predict that by the end of the century, temperatures will sharply increase in most regions, making life simply impossible in some. Places like India, Australia, and countries in sub-Saharan Africa are particularly vulnerable. But the temperature rise won't go unnoticed elsewhere. Even in habitable zones, the frequency of dangerous heat waves could increase by up to 16 times. Without coordinated action and crucial steps to curb temperature rise, this could lead to countless deaths. Research shows that global warming is already responsible for 1/3 of heat-related deaths worldwide. Based on these findings, experts forecast that mortality rates could reach record highs in the coming decades as the consequences of climate change become increasingly apparent. Australian and European scientists have developed a virtual model of Earth to better visualize global extinctions caused by climate change. Results suggest that by 2050, 10% of all plant and animal species could vanish, rising to 27% by the century's end under pessimistic scenarios. Scientists blame excessive resource exploitation, soil and air pollution, climate change, and other factors for this. The planet is said to be entering a phase of the so-called sixth mass extinction caused by human activity and climate change. Throughout its history, Earth has experienced 5 mass extinctions, and experts argue that we are witnessing another one now. Heat waves not only pose a threat to human health, but can also have serious repercussions for ecosystems and agriculture. High temperatures and water shortages could negatively impact crop yields, leading to reduced farmland and harvests, worsening food security, and economic losses for agricultural enterprises. The battle for humanity's sustenance is lost, with hundreds of millions dying of hunger, followed by the end, a moment when the planet exhausts its resources to sustain life. Predicting the future with precision is impossible, but looking at the rapid advancement of technology, it's safe to say that the world of 2100 will be drastically different from ours. Biotechnology will help us combat many diseases, improve the quality of life, and even extend lifespan. It can aid astronauts in adapting to long-term space travel by developing methods to protect against the harmful effects of space radiation, maintain psychological well-being, and ensure comfortable living conditions. Thus, biotechnology is a crucial tool for ensuring the safety and comfort of astronauts on long space journeys and for realizing the dream of conquering distant space. By 2100, humans will likely be actively exploring space. New spacecraft capable of interstellar travel will be created. They will likely harness solar energy for propulsion and gravity for acceleration. Quantum computing technology is in its early stages, but by the end of the century, it could revolutionize the field of computing. Quantum computers will tackle tasks that are currently beyond the capabilities of any conventional computer. They will model complex systems such as planetary climates and help us understand the laws of physics. Advanced nanotechnology will enable us to create lightweight and durable materials for spacecraft. It will also help us develop materials and devices necessary for colony construction. Robots already perform many tasks that were once done by humans. By 2100, robots will become even more advanced and capable of performing even more complex tasks. They will build and repair spacecraft, extract resources on other planets, assist in colony construction, and make them suitable for life. These and other technologies can be used to create systems and equipment needed for successful exploration of new planets and ensuring humanity's survival in case our own planet becomes uninhabitable or unsuitable for life. The end of the 21st century may become a pivotal moment in human history. Due to climate change and other environmental issues, our planet may become uninhabitable. In this scenario, humanity will have to seek a new home. Project Earth 2.0 aims to search for and explore exoplanets similar to Earth that could potentially become humanity's future home. Currently, astronomers have discovered numerous exoplanets with characteristics resembling Earth's. However, not all of them are suitable for colonization. So, which planets could become our new home? Kepler 452b is the most Earth-like of all known exoplanets. It orbits its star at a similar distance to how Earth orbits the Sun, within the so-called habitable zone where conditions are just right for life. Moreover, the star around which this planet orbits is almost identical to the Sun, albeit slightly more massive and larger. Being 60% larger and likely 5 times heavier than Earth, Kepler 452b exerts significantly more gravitational force and has a denser atmosphere. Massive planets receive more light from their stars, leading to higher volcanic activity and a higher concentration of greenhouse gases in the atmosphere. As a result, temperatures on Kepler 452b are much higher than on Earth, averaging 22 degrees C higher. However, the high temperature and dense atmosphere favor the emergence of plants. Liquid water, oceans, and rivers may exist on the planet, potentially supporting life. Scientists are unable to verify this currently, but based on its potential, the planet has received an Earth Similarity Index of 88%, higher than any other discovered exoplanet. The star system to which Kepler 452b belongs is located 1,400 light-years away from Earth in the constellation Cygnus. Traveling there with current spacecraft would take millions of years. However, by 2100, with the advancement of technology, this task will likely be feasible for humanity. Another candidate for our new home could be a planet called Ross 128b. It is the second closest known exoplanet to Earth after Proxima Centauri b. Located in the habitable zone of a red dwarf star of spectral class M4, Ross 128b has a mass 15% that of the Sun. This planet may also have a rocky surface and water, making it another promising candidate for future human habitation. Ross 128 is a very calm red dwarf, which means conditions on the planet should be moderate, with surface temperatures possibly close to those on Earth. Data suggests that Ross 128b is 20 times closer to its parent star than Earth is to the Sun, with a year on the exoplanet lasting 10 Earth days. However, since its star is a faint and cool red dwarf with a surface temperature almost half that of the Sun, the planet receives only 1.38 times more energy than Earth receives from the Sun. According to calculations, surface temperatures range from minus 60 degrees Celsius to plus 20 degrees C. Red dwarfs are among the coldest and weakest stars in the universe, making them very attractive targets for finding Earth-like exoplanets. They are being explored more frequently and in more detail. Such stars make it easier to detect small, cold worlds similar to Earth compared to Sun-like stars. What will life be like on Earth 2.0? In utopian scenarios of humanity's future, we envision the colonization of other planets with cozy homes, green gardens, and waterfalls. But the reality of possible life on a new planet is a more complex process, requiring not only technological innovations, but also adaptation to new environmental conditions. The first thing to understand is that even if we discover a planet whose atmosphere and climate resemble ours, it will still be different. For instance, on Earth 2.0, the oxygen content in the atmosphere may be lower, the pressure higher, the temperature lower, or the radiation level higher. One of the key tasks will be to ensure life support. Even if the planet has an atmosphere and water, with different composition and quality from Earth's, this will require the development of new water and air purification and disinfection systems to ensure human safety. Biotechnologies will be necessary to adapt plants to new conditions and to create agricultural systems resilient to climate change and soil composition. Differences in materials and resources on the new planet could also pose a challenge. Some materials that we consider common on Earth may be rare or absent altogether on another planet. This means we will need to develop new methods for resource extraction and utilization, as well as find alternatives to Earth materials. Security will also be a crucial aspect of life on the new planet. We will need to develop systems to protect against hazards such as cosmic rays, meteorites, and geological disasters, as well as build structures resilient to potential natural and man-made catastrophes. Another challenge will be the lack of infrastructure. People will need to build new roads, bridges, airports, and other necessary facilities to provide transportation and communication between settlements. This will require significant resources and technologies, which may be limited after a long journey. Technologies will play a key role in settling people on the new planet. For example, robots and drones can be used for building new structures, resource extraction, and cargo transportation. One possible scenario for colonizing the new planet is that it will become a site for resource extraction, while people live on orbital stations orbiting it. This may be because the conditions on the planet's surface are too harsh for human life, or because the planet's resources are more valuable than the planet itself. However, this scenario has its drawbacks. Life on orbital stations can be very costly and resource-intensive, and may also be associated with health risks for humans, such as muscle mass loss and bone tissue deterioration due to the lack of gravity. Moreover, if the planet is used solely for resource extraction, it could lead to its rapid environmental destruction and resource depletion. Life on Earth 2.0 will be accompanied by many challenges and problems, but also opportunities for creating a new society and civilization. Technologies will play a key role in settling people on the new planet, but cooperation and mutual assistance among individuals will also be required to create viable communities. Regardless of whether Earth 2.0 will be a place for human habitation or resource extraction, it is important that we treat it with respect and care to avoid repeating the mistakes that led to our native planet becoming uninhabitable.